An infantry operator moves through a ruined street. Not alone, not exactly. On the visor, friendly positions behind walls, a drone feed above the next block, a suggested route, a warning box around a window, a biometric pulse at the edge of vision. The promise is simple: see first, decide first, survive. But what if the map is wrong? What if the warning is fake? What if the machine is confident and lying? This is HiTechnomy. Look beneath the surface of the future. Powered by Alligence Labs. For centuries, infantry relied on direct senses: eyes, ears, maps, hand signals, instinct. Night vision changed darkness. GPS changed navigation. Radios changed coordination. Now militaries are trying to connect helmet displays, drones, weapon sights, biometric sensors, thermal cameras, AI assistants, and command networks into one live operating picture. The goal is not just a better equipped soldier, it is a soldier fused into a combat network. The question is not whether the technology is impressive, it is whether it works when everything is trying to break it. On the ground, the bottleneck is attention. An infantry operator may need to move, communicate, identify threats, protect the team, read terrain, conserve ammunition, manage fatigue, and make legal and moral decisions under fear, noise, smoke, and time pressure. The human body is already overloaded before the first algorithm arrives. This is why the AI-augmented soldier is not really about one headset or one weapon. It is about redesigning the flow of perception. The operator becomes a node, gathering signals, receiving signals, and sometimes passing a target or warning into a wider network. A helmet camera sees one angle, a micro-drone sees over a wall, a weapon sight sees thermal contrast. A command system tracks where friendly units are supposed to be. Biometric sensors monitor strain. Individually, each signal is incomplete. Together, they could become a machine-assisted sense of the battlefield. But this is where the human anchor matters. The operator is breathing hard, carrying weight, scanning doorways, listening for movement, and deciding whether an icon deserves trust. That trust is the center of the story. Because if AI is going to help infantry, it must do more than display information. It must decide what not to show. The AI-augmented soldier can be understood through three functions: see, think, and act. First, see. Sensor fusion pulls information from drones, cameras, thermal imagers, weapon sights, GPS, inertial navigation, squad radios, aircraft, satellites, and command systems. The ambition is a shared tactical picture, not just what one person can see, but what the whole network can sense. Second, think. AI decision support filters the flood. It may flag movement, prioritize alerts, translate communications, summarize updates, suggest routes, detect fatigue, or highlight an object that deserves attention. Third, act. The soldier becomes part of a larger sensor-to-shooter chain. A target spotted by one unit can be passed to another platform. A drone can confirm. A commander can authorize. A weapon system can respond faster than older command structures allowed. The shift is this. Augmentation is not mainly about making the body superhuman. It is about moving the soldier into a machine-speed decision architecture. The rifle remains local, but the operator's reach becomes networked. The soldier can see through other sensors, act through other systems, and receive a version of reality assembled by algorithms. The hardest layer may be the interface, a system simple enough to use while exhausted, under fire, and overloaded by motion, sound, and fear. The US Army's Integrated Visual Augmentation System, or IVAS, is one of the most visible attempts to build that interface. Developed with Microsoft and derived from HoloLens technology, IVAS aims to combine night vision, thermal imaging, mapping, training tools, and augmented overlays into a soldier-worn system. Project Convergence explores the broader architecture behind that idea, connecting sensors, shooters, command systems, and AI across domains. Other tools are more focused. Smart Shooter's SMASH system uses computer vision in a rifle-mounted fire control system to help time a shot when alignment is correct. That may be the real pattern. The future may not arrive as one super soldier suit. It may arrive as modular intelligence attached to sight, movement, communication, and command. In a lab, augmented reality can look inevitable. In the field, every gram matters. Infantry already carries weapons, ammunition, water, armor, radios, medical gear, and batteries. Add processors, displays, cables, sensors, mounts, and extra power, and the system becomes part of the physical burden. Public reporting around IVAS testing has pointed to familiar problems for battlefield wearables: discomfort, eye strain, nausea, field of view limits, reliability concerns, weight, heat, and battery life. The Army has continued revising the system, including IVAS 1.2, a reminder that combat AR is not solved. It is being wrestled into usefulness. Return to the operator in the street. A display that works during training may fog, flicker, lag, or distract under stress. A cable may snag, a battery may die, a route recommendation may be outdated before the next corner, and the interface itself can become a threat. Too many icons, warning boxes, messages, drone feeds, and route lines can turn the visor into a second battlefield. The system designed to reduce cognitive load can increase it. The best battlefield interface may not be the one that shows the most. It may be the one that disappears at the right moment. A connected soldier is powerful because information moves quickly. That also makes the soldier vulnerable wherever information moves. Modern battlefields are contested electromagnetic environments. Signals can be jammed. GPS can be disrupted. Radios can be intercepted. Networks can be attacked. Transmission itself can reveal position. But the deeper threat is spoofing. Jamming says, "You cannot see." Spoofing says, "Look here." A false, friendly icon appears in the wrong building. A fake target marker draws attention away from the real threat. A corrupted route guides the team toward an ambush. A drone feed is delayed, edited, or misread. The display remains clean. The confidence score remains precise. The reality beneath it has changed. This is the new digital fog of war. Not the absence of information, but too much information of uncertain truth. For AI-assisted infantry, verification becomes a survival skill. Can the operator compare the map to terrain? Can the team navigate without GPS? Can command trust the data chain? Can the system explain why it flagged a target? If not, augmentation becomes dependence. AI-augmented infantry is part of a wider global race in decision speed. The United States, China, Israel, European militaries and others are investing in networked soldiers, autonomous systems, electronic warfare, and AI-enabled command. Soldier modernization programs such as France's Phelan and Russia's Ratnik show that the push to digitize the infantryman is not limited to one military. Even when AI integration varies, the advantage may belong to the force that can understand the battlefield first, or to the force that can corrupt the enemy's understanding first. This raises hard questions. If an AI highlights a person as a threat, does the human decision remain independent? If a recommendation arrives with machine confidence during a 5-second window, is human control meaningful or ceremonial? If an AI-assisted strike goes wrong, responsibility spreads across the operator, commander, software developer, contractor, training process, data pipeline, and procurement system. Accountability becomes harder to reconstruct. There is also the risk of abstraction. A real person becomes a red box, a probability score, an icon in a simplified interface. The concern is not that soldiers literally mistake war for a game. The concern is that design can compress distance, urgency, and moral attention until consequences feel less human at the moment judgment matters most. Machine speed compresses time, but law, responsibility, and judgment require time. Return to the operator. The screen goes dark. The network is gone. No drone feed, no route overlay, no friendly icons. What remains? Map reading, radio discipline, hand signals, terrain sense, team trust, independent judgment. The oldest operating system in infantry. Training. The best future soldier may not be the most augmented soldier. It may be the one able to move between two worlds, using AI when it helps, and functioning without it when it fails. Here is the thought experiment. If a machine draws the battlefield before the human sees it, who is really choosing where attention goes? The future of infantry may depend on preserving human control, not at the trigger, but earlier, at the moment perception is shaped. The question is not whether machines will enter the soldier's world. They already have. The question is how much of reality they will be allowed to define. If you enjoy deep dives into the technologies shaping our future, consider subscribing to HiTechnomy. This is HiTechnomy. Look beneath the surface of the future. Join us next time as we explore another technology, system, or breakthrough shaping our world. Powered by Alligence Labs.